all of that resiliency that you gain, all that redundancy that you gain, and we're putting it into a package that's easy for you to work with. It's as simple as a single motor fan, yet has all of these additional features that you need. So some of those things, the highlights, multiple motors operating in unison with a simple speed input. I said the word resiliency. You hear me say that quite a bit, sometimes interchangeably with redundancy. While they're not quite interchangeable, a lot of times we're talking about the resiliency of a system, meaning its resistance to any serious failures that would cause major downtime. And so that's what I'm referring to. And so the Q-PAC system is resilient, maintains airflow, even in the event of a simple failure of like a single motor fan. Again, we talked about it functioning as a simple device, a single device, one point of connection for power and control. Gone are the days of needing to run conduit and home runs to every individual fan. With the Q-PAC system, all that's provided as part of our kit, prearranged. You can see it there in the picture. And we've got proven performance. It's not extrapolated and ambiguous. And we actually provide all of our performance curves, our sound data and stuff like that through our submittal data, through our systems. So single device functionality. Why? Well, I was doing a compare and contrast just a minute ago, and we talked about single motor fans. I said fan arrays, and then now the MPF. The reason why we're pulling MPF off to the side and not considering it as an array anymore is because at Q-PAC, we built arrays. We did it for a long time. We were a Daikin modifier. And I like to think that we built some of the best arrays that are out there. The difference between a single motor fan and that fan array is you go from one item to multiple, and sometimes that includes complexity. And so what we've done is re-engineer and re-architecture the way we built this system to where you get the simplicity of a single motor fan with all the benefits of a fan array. So for the Q-PAC MPF, it's going to be available fully assembled or in a knockdown version. So you can get this thing, it can come in air handlers from OEMs. So manufacturers can drop this thing into their air handlers. They can also be field installed. So you can get a blank section or a cabinet or a built up air handler, and you can put the Q-PAC system in. And then one of our very popular kits is our retrofit kit. It comes down as a knockdown kit. Everything's small, hand carryable, and you can easily install that. So talk a little bit about scope. I'm not going to read everything here on the screen, but some of the differences. With the single motor fan, you've got a lot of times simple one AC motor that you're connecting to. But sometimes there's an additional scope there. We're adding and connecting to a VFD, and those bring on their own complexities. Whereas fan arrays, somebody's going to give you a product with a bunch of cubes or fans or fan housings or plenum fans that you've got to figure out. You and your controls and your electrical contractor have got to figure out how you're going to interface with all of those things, how you're going to connect to them, how you can communicate. And oh, by the way, can we interface with our current BAS system if we have one? And so that frequently involves on-site fabrication and building. One of the things specifically is the bulkhead wall. With the Q-PAC system, our fan frame, and I'll talk about that in a minute, is designed in such a way to where it fits the existing area of the space and no bulkhead wall is required to be designed. Again, Q-PAC uses multiple fans and multi-motor fans. We use EC fans currently. There's always new technology coming around the corner. We were at AHR this past year, and this is, I think, last 3 years, we've been seeing a fan that's comprised of printed circuit cards. So no more coils, printed circuit cards. That's a pretty fancy thing. We could talk about that later. But no VFD is needed with the Q-PAC system. Really, all we need is high voltage to run the system and a 0 to 10 signal, and we can run. We've got built-in PID loops through our system, and we can interface with your current system. So the idea there is it delivers that modularity and the benefits of that array, like I've already said. So speed modulation, we just talked about that, 0 to 10. So not to stick on this for too long, but single motor fans, AC motors, they're designed to run at a constant speed. And they always have been. That's a 100-plus-year-old technology. It runs at one speed, and it runs at 60 hertz, and that's all you get. Well, the addition of a VFD gave us the ability to control and turn down that speed. And that was a great feature that came along. And since the advent of that, VFDs have gotten to be a very commonplace. Almost every AC motor it's in an application, whether that be HVAC or if you're talking about pumping fluids, stuff like that. Most motors are coupled with VFDs now. Along comes the fan array. The fan array generally includes a bunch of AC motors, sometimes different types of motors, all coupled with either one VFD or multiple VFDs for redundancy. Whereas the MPF, all we need is a speed signal. Our fans will run off of a 0 to 10. And if you buy our premium package, you can use our built-in PID loop. Resiliency. So I said how I'm interchanging that word oftentimes with redundancy. The idea being single motor design is inherent risk. You could lose airflow. So in your single motor configuration in those first pictures we saw, if that motor goes down, if you have an issue with that shaft or the belt, if it's belt driven, or if it's just a single blower like with a squirrel cage, if that thing goes down, you're down on air. So the only way you can have any form of redundancy is if you double up. You have two units in the place of one. And so with that being said, the fan array comes along. Like I said, we built these for a while. Multi-fans, it adds the redundancy. But redundancy implies extra that you don't need, and it's only there in case of emergency. What we've done is we've built something that we believe is more resilient than that. The idea being, instead of having a redundant system, you've got a system that's resilient. It won't fail. And if any individual component within it does have an issue, the rest of the system is designed to ramp up and meet the requirements, so you have a zero downtime. So that's where I talk about the resiliency. And again, we use the motorized impellers, and this simplifies any kind of replacement time. So if you're in a site that does have an individual failure of one of these EC motors, literally one of those things can be swapped out in just a few minutes. And so the benefit of that is no more craning in large objects, rigging in large objects, having to do major shaft and bearing alignments and stuff like that. Gone are those days when you can just take those things and replace them. Now you can really just swap in a small multi-motor system. So repair and replacement, I keep getting ahead of myself. Single motor fans. One of my first jobs was wiring electrical motors, and we had a machine shop and rebuilt shafts and replaced bearings and stuff like that. And that was a skill set that was pretty common years ago. But a lot of that stuff's been sourced overseas, and now it's actually more cost efficient and easier to just keep spares. And so you've got 20, 40 horsepower AC motors, and then somebody's got a spare 40 horsepower motor on a shelf somewhere or in a space somewhere. And if that one 40 horsepower goes down, they're going to crane in or cart in this large AC motor. And in order to do something like that, a lot of times that's not going to fit through the opening of an air handler. So you're going to have to knock out certain components. You're going to have to take out doors. You're going to have to move obstructions and stuff. Then comes the fan array. So modularity by design. A lot of the kits out there that exist that aren't the Q-PAC system, they require a whole lot of disassembly, a whole lot of technical knowledge, whereas our kit comes with very simple fasteners, literally instructions how this system gets put together, and it's a knockdown. Literally, you're just going to assemble it in the airframe or in the airspace. So, big redirect. Q-PAC MPF puts the added focus on accessibility and the user experience with the following added features. So this is built to order. I'm going to go into the parts in just a second, but it'll fit in any air handler. That's either a built-up air handler or one of your custom or semi-custom sections or boxes that you can get from any of the air handlers. Our adaptive fan frame eliminates the need for a bulkhead. I'll go into that in just a second. The frame design provides structural stability with minimal components. So you can see there, we've got a multi-motor plenum fan, and the EC motors themselves are connected to that fan frame. And that fan frame can grow as large or as small as you need it, depending upon the air handler size internal requirements. So lightweight components. Why lightweight? Well, we've had to change these too many times. We spent years trying to perfect the design. How can we easily swap in and swap out a fan to stop, or I say fan, to swap in and swap out an EC motor to stop downtime, to cut it in half, or to make it to where downtime is limited? or not at all. And so in our plan and in the MPF, what we're doing is we're designing this resiliency to where if one of those fans goes down, you actually don't have to stop the system. You have no loss of air. You're not even limping in an N-1 configuration. You lose one of those individual motors, the rest of the motors ramp up based on demand, and you still meet your requirement. Now, when occupancy is low, either the end of the day or over the weekend, then you can have your crew come in there and swap one of those fans out, and it can be done in 5 minutes. So that's the lightweight components. And then simple BMS integration with Modbus RTU and BACnet IP. So the idea is this can fit in any air handler in any building, whether that building have an advanced control system or whether that building have a primitive or not existent control system. In fact, you install one of these and the BMS is not even going to know that the old fan's gone, the new fan's in there. And we've seen that happen several times on retrofits. So the components, got a cool exploded view here. We can see the motorized impellers here on the left are the EC motors. Now notice those are, not any specific brand. At Q-PAC, we're agnostic to what we're using. We're going to use the best technology that we can support to make sure that your unit, keeps running and delivers good air for you. So the fan frame, again, we talked about this, designed to fit any air handler. No bulkhead wall or field fabrication required. A lot of times you're used to seeing a squirrel cage, or you've seen a large inline axial motor, and then there's some kind of connection point and then a bulkhead wall. No longer is that required. This will fill up the space. There's no sheet metal fabrication or anything. So as long as we have the correct measurements, this will fill the entire space and it'll cut down any type of installation or work that's required. This thing can just drop right into a system. We use very simple fasteners and ledges, things that are going to hold the weight of the fans. You'll notice that the frame wires are already on this picture. And so those frame harnesses are all single run back to the patented controller that's there. And those are all pre-made and skewed by us here in our factory. And so what that does for us is it means that we can actually crank out these systems really quickly. And we've got SKU and part numbers. So if there's ever an issue in the field and one of those needs to be replaced or shipping issues, they happen, then we can literally just make one of those here in our factory and have it sent out overnight to you. So the plug fans, motorized impellers, inlet cones, and a mounting frame, pre-wired harnesses. So it's kind of hard to see there on the black background, but there are actually motor harnesses that we install here in the factory. So we take these motorized impellers here and we do basically a check on these to make sure they all run like they're supposed to, so we can cut failures down to almost nothing. We wire these in-house and make these harnesses. That way, if there ever is a failure out in the field, one of these can be shipped out and can be literally installed in minutes. There's just a couple of plugs that you're plugging in. So no field addressing, no location specific harnessing. A lot of times when arrays are bought, the individual harnessing that I've talked about, that doesn't come with the system. Someone else has got to include that in their scope, and they've got to build that by hand. And that's going to be at least 2 runs of conduit, high voltage and low voltage, to get these systems running. In an AC motor, it would just be one broken in between by the VFD. But again, no field harnessing or any location specific addressing or tools that are needed. And we use standard models right now. We've got several in our catalog, 480 volt and 208 volts, or 230 if you prefer. 3-phase to be correct there. So our fan controller, this is our patented fan controller. There's a single point connection. This is where your controls and electrical contractor is going to land, and that's the only place they're going to have to land. No additional wiring to all those fans like we talked about. This thing supports Modbus. We also have a fan controller that supports the BACnet MSTP, and we also have IP that's coming at the end of this year. So the BACnet IP controls that people have been asking for, that's going to be directly in this controller. It monitors the total airflow and the motor power consumption. So that's something that you didn't get from some of your basic systems. So you're going to get some monitoring, and a lot of those points are going to be over BACnet if you're interested in them. There are some analog points too. You can send an analog run signal. The individual MPF, we're calling this a single fan. Remember back to that battery picture? Can a battery be made of multiple batteries? Well, Q-PAC poses the question again. Can a fan be made of multiple, in this case, motorized impellers or multiple fans? In this case, this is a single fan. It's installed and connected like a single fan. And it can have up to 9 motors with a 95 amp rating, simple connections, no field wiring of those motors, uses a standard conduit knockout. The idea being if you need more than 9 fans to achieve your schedule or your CFM and static, then we can put multiple of these. And so this can scale down to just 2 motors and all the components you see here. And we can put 2 of those side by side and they can be connected with our adaptable frame bulkhead. You need 3 of these, that can be done. And so as your demand grows larger, the adaptability of this means that once we get up to 95 on a single MPF, then we'll put another MPF just right next to it. And so they're a lot more dense that way, and it's a building block for the Q-PAC system. So harnesses, kind of already talked about that. So power cable, control cable, there's also a pressure tube there. And these are UL VW1 compliant harness sleeves. And so the point being, these are pre-made. We're also monitoring air. We're monitoring the velocity at each one of those fans. We're also pulling a delta against the wall so we can give you a local interpretation of CFM. And we can also monitor the effects of the system and what's happening with these fans in real time. So, and these are all dedicated. They run back to that single point controller. And they're very fast to mount. If you see one of these systems get installed, there's already pre-punched holes in this frame, and even the zip ties themselves just slide into the pre-punched holes, and you end up with this uniformity and easy to maintain, clean looking finished product. So application, where do you see this the most? Anywhere comfort cooling is the application. So we see that really commonly in places where we're airside, but we see that with chill water systems. If there's a large commercial buildings, institutions, or entertainment places that have chill water, then this is where the Q-PAC fits the best. These are centrifugal motors, and we apply those currently in these type of applications. We really shine in institutions that have critical air requirements, such as hospitals, healthcare facilities need to maintain positive pressurization in certain areas, or they can't afford downtime. And the resiliency of the system never going down or never losing airflow, even if there is a minor hiccup inside the system, is where we really shine. Same with these sports arenas. I mean, imagine you sell tickets to the Super Bowl, everybody's there, and then you have some kind of HVAC catastrophe. You don't reschedule the Super Bowl. It's hard scheduled. And that's the same with a whole lot of other venues like that. So we do see this also in some light industrial, like warehouse, distribution centers, clean room, manufacturing type stuff. Our factory floor has our Q-PAC systems in it. I think we have probably one of the nicest ones where we put our money where our mouth is and have a nice system operating out there. But also in transportation facilities, you see these in airports, train stations, and other places like that. So, what it is not. The Q-PAC fan is not intended for corrosive or explosive environments. That's just not something that we're doing. Also, heavy industrial facilities kind of falls under that same realm. If you've got process cooling or heavy industrial facilities, it's something that we have to look at to decide whether that's where we want to work, because things like corrosives, high saturation, explosive, high dust, exhaust, and things of that nature may not be compatible with our system. Also, high temperature applications, so above 104 degrees Fahrenheit, which is pretty hot for an Airstream, or 40 degrees Celsius for those that aren't using Fahrenheit. And then the super wet or high moisture. Now I don't mean humidity of Florida. We're a company that's manufactured here in Florida, and we have a lot of our systems. While it is humid here in other parts of the country, we can operate inside the Airstream where that's the typical saturation. But if we're talking about submersible or large amounts of moisture and water being pulled across the air mover or the fan section, then that's a problem, such as like cooling towers and stuff like that. Yeah, so I think I kind of went through that pretty well. So specifications. So Selecting the Q-PAC fan for your application is based on these three factors. What are your air handler dimensions? So we need to think height and width of the internal dimensions. So a cross section of the airstream. A lot of times, a quick go-to is what is the coil face measurement? But the truth is, we want more than just a coil face measurement, because a coil face measurement doesn't extend all the way to the edges of the air handler. We want the internal dimensions of the air handler. That way, our fan frame can be designed to fill up that entire space, and no field modifications are needed. Fan performance. So the requirement of CFM and static. Those two things, sometimes there's a push-pull between those things, but we need to know what your schedule is for your fan, what is your required CFM and static. Also, power. We need to know what kind of power you've got, the location that we're going to place our controller on what side. And so let's say you've got a controller that you need the power to come in because of where it is now on the left side in a retrofit application. Or if you're going to be running all of the main power into a new building and it's all coming from the left or the right side of the system, as we look at the fans with the air blowing in, or the fan with the air blowing in our face, then we need to know what side that's going to be on. Also, there's optional accessories for our system. So we've got a control panel. It's external. It's fuse disconnect. And those are things that, so touch screens, physical panels, and stuff like that become necessary to really solve the majority of the problems that we're solving now. Dimensions. So I was talking about this, just the height and width. So existing flange. So we use a 5/8 to 1 1/4 flange, and we can add a 2-inch flange to flange measurements. If there's no existing flange, a set of perimeter angles is necessary. So what this means is, if you've got a built-up air handler, if you've already got a custom air handler, and there is an existing flange, we'll mount directly to that. Now, let's just say your existing flange is outside of that, then we'll work towards having either our set of perimeter angles that can mount directly to that flange, so you can be physically mounted in the cross section and you can withstand the forces that this system is going to provide. But we need that measure wall to wall and floor to ceiling, sorry, and no offset. So we don't need you to provide dimensions minus a 1/2 inch or anything like that. Exact dimensions, and we'll build our system to fit that.
Hey, James. We actually have a question in the
A
chat.
question.
Yes. Pedro has asked, how is the performance of these fans under seismic loads?
That's a really good question. So I was intending to take the questions after. So if that's okay, I'll get to that in just a minute. We're almost nearing the end of the slide deck, but that's a really good question. So Pedro asked, how do the fans handle seismic conditions? So performance. We specify the required airflow based on the performance of the existing fan. And so when you provide us with those specifications, the Q-PAC system, the Q-PAC fan, it can generate between 1 and 9 inches of static and 5,000 CFM and up. Now, obviously, there's a give and take there. If you've got a higher CFM, you may have a lower static, and vice versa. And so there is an efficiency sweet spot, but that's the general requirements, the minimum and the maximum of our system. So we can go up to 9 inches of static. And the single MPF we've seen with the 9 motors, we've seen up to 65 and sometimes as much as 80, depending upon static, 80,000 CFM with the single one. So options, I was talking about that left or right. Your cable conduit power and controls come in on the left, and that we're going to put that box on the left, and it would just kind of be inverted if it were on the right. So we need to know which side you want that to be on. So all of those harnesses match up. We're gonna label these as fan 1, 2, 3, 4, 5, or motor 1, 2, 3, 4, 5, 6, 7, 8, or whatever. And we need to know where those are going to be. That way, each one of those harnesses can be made custom, and they work where they're supposed to work. So no surprises during an installation. So that connection point. Also, different controls packages. So in order to be a full-fledged solution, we want to be able to fit into anybody's building in any airstream. We do have a premium control package. If someone needs features such as touchscreen, heads-up monitoring. There's an HMI screen, a handoff auto switch, almost like a bypass, physically on a panel. You need that, or you need a fuse disconnect. We can provide that, and that includes things like BACnet and, like we talked about, IP. But if you need something less Intense is a premium, something like a basic. I just need a fuse disconnect. I don't need all the additional PACnet features, but I do want to have this control panel because I've got an existing VFD or an existing panel that I want to replace, and we provide that. Also, you can get this system with just a fuse disconnect, which is just a smaller external device that you would put in between where the power comes in. And then this can be ordered as fan only, no controls at all. And so you can interface directly with that proprietary control panel right there. Your 0 to 10 signal can be sent there, and your power can be sent there, and you don't even need anything external. And that works really good for like rooftop units and units that have existing controls. So our control panel enclosures are made here at Q-PAC, and we also do provide backdraft dampers. And so it's case by case basis. Because backdraft dampers do tend to be a leach in the airstream, we recommend that you don't need those specifically. But if you've got an application where the spec or somebody is specifying and they want to require backdraft dampers, they can be included in the Q-PAC system. There's our control panel. So if you can see those on the left there, that's the basic, no HMI, no touchscreen. The one on the right, that's the premium. They share a lot of similarities. They both have the handoff auto switch up at the top, which is similar to your bypass that you've heard of on a VFD. But in this case, when you switch that into hand mode, you're actually able to turn the potentiometer, the dial there, and you're able to set the speed of the fan. So in the event of a loss of controls, or you need to, for some reason, take manual control of this, you can do that right there at the panel. And the standard features for our control panels, 100,000 KAIC fuse disconnect, accepts 0 to 10 modulation. That's that speed control that we talked about. I was just talking about the handoff auto. These are UL 508A rated panels. We make these in-house here at Q-PAC. We're a UL 508A panel shop. Supports up to 4 Q-PAC fans or 4 MPFs, meaning that we talked about the MPF being up to 9 fans. You could support up to 4 of those in one of those panels. Now, obviously, the panel grows as those components grow inside there, and it can shrink down too when you have less than that. So we've got 2 types, indoor and outdoor. If you've got an indoor application and it's not going to be exposed to the elements, we recommend you go with that indoor. The outdoor is designed for more outdoor type environments where you need to have the higher NEMA rating. So premium features, I kind of already went through this, so I won't go back over that again. And these panels, they're not required. So if you just want the system without the control panel, that can be done too. There's the fuse disconnect. Lovely picture there. Fused overload protection. It's a quick make or break. So it's the knife style. Square D is the one we've got in the picture here. Dual cover interlock. You got a little viewing window so you can see whether it's in the open or closed position, or for the non-electrical types to be on or off. And then again, rated NEMA 1 or NEMA 3R. And these are tested in accordance with UL 98 and NEMA KS1 standards. All right, fun part. For everybody in this group, I think the fan configurator is something that you're going to like to see. For starters, this is the exact view of what it looks like on our website right now. So if you go to qpac.com, no login required, no credentials, we're not behind any kind of paywall. You can go design your fan. In fact, the first page when you get to the website, it says design your fan. You click on that, you can put in those measurements that we talked about to size your fan, and you'll be able to receive all of the specifications and get all the information you need and be able to see the pricing and order a system directly from this. Now, if you need further stuff, additional options like some of the solutions we were talking about, we'll be glad to help. There's a team standing by that'll help you get those ordered. But if you're curious, you want to see, hey, would Q-PAC fit my application? Then you're going to put your dimensions in there, and you're going to see some of those things like what kind of resiliency am I going to get? What kind of FEI will Q-PAC provide me? What kind of efficiency am I going to have? What is my rated power consumption? These are all going to be in here. And yeah, this one does really automatically selects based on our criteria that we've put in there, kind of like the recommended system, the Q-PAC recommended system based on your requirements. While we do have options, so a lot of times you pull one up here and you're not 100% happy with what you get the first time, then we could run it through the background of our actual selection tool, and maybe you've got three different options. So you've got like a good, better, best. If you've got customers that want to choose based off of different metrics, whether that be efficiency, resiliency, electrical load, or something like that. So this is our full-fledged selection tool. This is given to our channel partners that we work with. This one is a login requirement, but we can get users access to this. You can get in here and you can fully configure a system and see what the price is going to look like. You can see the sound data, the extrapolated sound data that we're going to provide based off of the fan from the manufacturers. You can see the performance curves. You can choose based off of performance. You can choose based off of resiliency. You can choose based off of MOCP, i.e. electrical, and you can see all of those features. Not only that, but with just a click of a couple of buttons, putting in those measurements that we talked about, you'll be able to get full submittals and quotes just by clicking a button. You'll get one right away. And this is a submittal that you'll be proud to submit directly to your customer. Yeah, here's some more quips. This is what we call it, with Q-PAC. So it's got the Q in front, QUIPS quips. Again, we talked about this price, efficiency, MOCP, and it says redundancy here on my slide, but I mean, we talked about how I'll interchange that word with resiliency. So you can manage these features. You can also choose some of those additional requirements here in this system. So if you do need the optional premium control, then you can select that with your system, or the other options, without or with the basic or without the controller itself. And then you get to compare different systems. And so that's what we're showing here. I know it's small, probably too little for you to read, but you get to compare some different selection choices to see what's going to fit, your needs the best. Here's all those drawings and submittals that you're going to get. So the first thing we see up here at the top is the submittal. So you're going to get a representation of what that system's going to look like with the fan curves, the minimum, maximum capabilities, all of the operating points. You're also going to get what we call the 3-view diagram, which is a side and front and top down look at the system. And then you're also going to get the assembly diagram and then the harnessing diagram right there. And not to mention, you'll be able to print out a full-fledged quote, and that's on the right there. Configurable drawings. So if you wanted to get a DXF or a PDF, that's all at the touch of your fingertips. And this is, guys, you have access to this. You can get in here, you can log in, you can literally 5 measurements, you can create a system and print all these things out. And you're not waiting for days on a phone with someone trying to get a configuration to figure out what the capes and limbs are. So I recommend you guys get access to this. All right. So for more information, there's my email address there and my counterpart, Salem. He's actually here in the call with me. You want to say, hey, Salem?
Hey, what's up, everybody? My name is Salem Lamerkowski. I'm another field marketing engineer at Q-PAC. Great job today, James. It looks like we did have one question in the chat there. Pedro was asking about performance of the fans under seismic load. You want to take that one, or you want me to handle it?
I get it.
All right.
All right. So Pedro, that's a really good question. We are actually in the process of working on our OSHPOD certification. And so if you're talking about seismic load in the sense of OSHPOD, then we do not have OSHPOD certification for our system currently. Here's what I will tell you. You can purchase systems through manufacturers, I think you already know this, that have the OSHPOD certification. And we have put systems as a retrofit into those, but they do have to have the initial OSHPOD. So the idea is that sometime in the near future, we will have our OSHPOD certification to where we'll have the shake test that's needed. It's kind of difficult. We're in the process of building an AMCA 270 wind tunnel. And as soon as we've got that up and running, our next big hurdle that we're going to tackle is OSPOD and being able to open up the West Coast where those requirements are very, very heavy. And I'll defer to Salem to see if I answered that as best I can.
I think you captured all of it there, James. That OSHPOD rating is something we're working on, and I believe it should be ready by AHR 2026. So we're very looking forward to debuting that in Vegas.
Oh, nice. OSHPOD at Vegas. All right, hold them to it. We'll see. Were there any other questions? Do we have anybody want to raise their hand or?
Free to come off mute, guys.
Not everybody at once. Pedro, you were the only one brave enough to step up.
Pedro, if you're still on the call, are you based in the Southwest or the West Coast? Is that why you're asking? All right, I'll take that as a solid maybe. East Coast, okay, gotcha. Maybe South Carolina. There's actually a little seismic activity over there.
More recently, yeah, right. There has been a little bit. See what else we got in the chat. See some repeat people here. Matt, you're back. Thanks everybody for joining. We're going to leave it open just for a few more minutes, maybe, so they can ask questions. See what comes up.
I see Rich from CHC is there. Rich, thanks for showing up. Things are well.
For anyone
Yeah.
who's still on, there will be a survey coming out about the webinar in the next couple of days. We'd love if you take the survey and let us know any feedback you have. That'd be great. Thank you all for joining.
Yeah, and as a reminder, you can go configure your fan on our website. So everything that I was telling you there, you can put it to the test and see what your fan's going to look like, at your leisure. We'd love to have your feedback on how well it performs and if it's what you expected or if there's any features that you think that should have. Any additional information, whether that be articles or documents that you're interested in reading. If you're interested in pulling up IOMs on the Q-PAC system so you can study it and understand it better. If you're going to be building scopes for jobs or you're doing a specification, then we've got specs that we've helped people write before that we've assisted with. Salem been working on one for quite a while that he's used, and it comes pretty handy for somebody to put that directly in their spec book. Here we go. That's a good question. So Pedro's the only question asker today. Pedro asks, up to how high can you stack the fans? So back to the architecture thing, we call the Q-PAC fan is the MPF, the multi-motor plenum fan. And I talked about it being up to 9 fans. Well, we can go currently just with that single MPF, we can go 120 inches tall. It's 120, right, Salem? Yeah, 120. So we can do 120.
Well, actually, James, it's 140 inches high. I think in Quibs, the
140.
maximum dimensions are going to be 280 wide inches by 140 inches high. So, but just remember, we have custom products available as well. We have a whole separate team that can assist with selections going outside of that range. A heavy steel tube frame. So that's a good question. I think that typically the product doesn't really need any additional reinforcement. If you're going to go, it also depends on kind of how you orient the MPFs per se. So if you have a larger space, larger width potentially, and you have a less performance requirement, then that might be a situation where you'd want to have some kind of structure in the middle, like a coupler of some sort. But that is a great question. I do think that structural concerns are definitely more valid as you get into those much larger systems. So if you have 3 or 4 MPFs, then you may want to look at some additional structural components. But the way that the Q-PAC fan frame is designed with the channel on the back, that's actually going to provide all the structural rigidity for the product. So in our lab, we did some testing and looked at a 9-pack, and they were able to pressurize the cabinet up to about 11 inches of static pressure without any, with about, I think it was maybe under a half inch of deflection off the center point. So it's a very structurally sound product. No, so Pedro, there's a channel that's on the back of the whole product, right? And that's going to be built by when you assemble it inside the air handler. So if you have some more questions you want to walk through it, I think James and I'd be happy to help you kind of visualize things better, maybe on a follow-up call if you'd like.
Yeah, Pedro, I'd love to show you the way the adaptive fan frame is put together. And so what you don't see in the pictures that I show are the channels that we build with these, and the frame comes together. The two pieces come together. They sandwich together. We're actually building a tube for structural rigidity that's going to provide a support for any kind of axial thrust. And so when Salem talks about the deflection that was measured there, it's designed to be able to handle the 11 inches. If you've got an application, remember we talked about Q-PAC being 1 through 9 inches of static. So if you got an application over 11, I hope you have some kind of high static cutouts or something like that. But the frame is designed to handle the 1 through 9, like we talked about. We pushed it a little bit beyond that for testing, and so it holds together. Yeah, that's exactly right. Yeah, so if you think tube DOM tubing, some of the strongest stuff that's out there, even better than just a simple angle. So we create a channel there in the back by bringing the two pieces together, and that comes together to provide the rigidity that we need. So it's almost like a boxed in channel.
Actually, if you'd like, I can just pull up the assembly stuff real quick. Give me 1 second.
Yeah, we like these questions. Make us pull some stuff up. I'll stop sharing there, Salem, and let you open that up.
All right, let me share my screen and I'll show you guys what I'm talking about here. All right, so this is captured from our assembly instructions document. So there's a lot of documentation. James covered that earlier, I believe, but this is a great piece that our team made. So as you can see, this is kind of how the perimeter angle flange piece looks when it's kind of mounted inside of the unit, right? And the Q-PAC is actually going to mount to the left or the rightmost section, and it's one panel at a time. So Pedro, if you can take a look at this, you see how there's that bent channel on the back of the section of the fan panel? So that piece is going to connect with the next panel in the section. So the leftmost flange here of that second panel is going to connect to the interior right flange inside of the first panel. And then once you've got that connection made, or once you've got the sheet metal pressed in there, the holes, there's some holes here on the fan panel. Those are going to connect with the back of the channel, and then that's where you're going to shoot your self-drilling sheet metal screws through. So that doing this along the entire length of the product is what's providing that structural support. So that channel is what's holding it in there, holding it together. Does that help?
Yeah, it looks like Pedro asks, he says, for plane loads, do you need any kind of corner gussets? No, our adaptable fan frame is designed to be able to handle the ranges in which we provided. You could always go above and beyond, right? And so when we talk about that OSHPD certification, there could potentially be some push-pulls where OSHPD is required. I've seen sections that wouldn't normally have cabling and turnbuckles when you shipped anywhere that wasn't required to have OSHPD, where turnbuckles or corner gussets were required. But currently, our system without the OSHPD does not require any kind of corner gussets through the 1 through 9 inches specified.
All right, awesome.
All right. Thank you so much for the engagement. Are there any other questions from the last two folks we have on the call? You guys made it all the way to the end with us. Awesome. Well, thank you both so much. If you have any questions, you can reach out to marketing@qpac.com, like you saw in those emails, or you can reach out to Salem and James. They have their information in that last slide. And thank you so much for joining us today.
100%. Thanks, everybody. Have a good one.
Have a great one. Thank you.